Okay, Honors Algebra 2, we are going to do 4.9 here, which is on page 18 of your notes, Transforming Polynomial Functions. But before we do that, I'm on page 18, question 5, example 5 in the note packet, because we didn't get to that in class. So I want to cover this problem, and then we will move on to lesson 4.9. So example 5, page 17 of the notes. You are making an open box to hold rubber bands out of a piece of cardboard that is 6 inches by 10 inches. So here's that piece of cardboard. We have 6 inches by 10 inches. The box will be formed by making an X by X inch square cut out of the corners as shown in the diagram and folding up the sides. So each one of these little dimensions is X by X. We're going to cut those little corners out. You want the box to have the greatest volume possible. So write an equation for the volume of the box as a function of the length of the cut X. So we know volume of a box is going to be length times width times height. And so we will call this the length right here, length. And that length is going to be the whole cardboard piece from end to end is 10, but we're going to take this X out and we're going to take this X out. So that means 10 minus 2 of those X's. And then our width is going to be the entire cardboard width is 6, but we are going to take again this X out and this X out. So that's 6 minus 2X. And then the height is going to be, when you fold it up, how high will it fold up? X. So therefore, we can say our volume equals 10 minus 2x for our length, 6 minus 2x for our width, and then our height is x. Let's go ahead and FOIL that out. I'm going to move this x right here to the beginning. And multiplying 10 minus 2x and 6 minus 2x, I get 60 minus 12x minus 20x plus 4x squared, which gives me, I need to multiply this x in and combine like terms, so that, and write it in standard form. I'm going to do that all in one step. So I have 4x squared times x is 4x cubed. Negative 12x minus 20x is negative 32x times x is negative 32x squared. And then plus 60 times x is plus 60x. So there is the equation for the volume of the box as a function of the length of the cut x. All right, next it says use a graphing calculator to find out how long you should make the cuts to maximize the volume. So you put this equation into your graphing calculator, you are going to get a graph that looks something like this. Okay? And I think you should put that into your calculator because you need to remember how to find these points that we're going to find. And the maximum volume will be, so this is x, which is the depth of the cut. But the y-axis here is right here, the volume. So when is my volume the highest? The maximum would be right there. And so I need to find the coordinates of that point, which you guys know how to do on your calculator. You should plug in some things and you would get the point, that maximum point there. It's a relative max because the graph continues as this arrow shows, it continues. But remember, when you're doing these problems within story problems, there's limitations. For example, the volume can't just continue to get greater and greater and greater because we have these limitations of a piece of cardboard, which is 10 inch by 6 inch. So anyhow, we need to find that local maximum, and you find that point of intersection to be 1.21 and 32.84. So x value, the depth of the cut, is 1.21 inches, and the maximum volume will be 32.84. But in this problem, it's saying how long should you make the cuts to maximize the volume. So to make the cut, The cut should be 1.21 inches. That would be your answer to that question. What is the maximum volume? That would be the max value. Oh, yeah, volume is 32.84 inches cubed. What will the dimensions of the finished box be? All right, well, we said right here, we said the length is 10 minus 2x. So the length is going to be 10 minus 2 times 1.21. The width is going to be 6 minus 2 times 1.21. And the height is going to be 1.21. And these are all in inches. And so you do your math there. You get 7.58 for the length. You get 3.58 for the width, and the height is right there. So there's our dimensions. All right, so there you go. That's the end of 4.8. Moving on to 4.9. What we are going to do here is we are going to transform polynomial functions. You've already done a lot of transformations. All of the transformation rules are the same. And so here we go. You can perform the same. We're on page 18 of the notes. You can perform the same transformations on polynomial functions that you performed on quadratic, square root, exponential, and logarithmic functions. The same transformation rules apply. Review the rules. So if you, as we go through this, if you don't remember those rules, you need to pull out your old notes. I think we started talking about it in Unit 1 or 2, these transformation rules. You need to review those and know that when you're within the function, you do the opposite. Outside the function, you do the same. So anyhow, here we go. Graph the function f of x equals x cubed by completing a table of values. So right now, we're just looking, this is a parent function, right? X cubed, a very basic function. Let's find our anchor points. When I put -2 into that equation, that means I have -2 cubed. I get -8. And when I put -1 into that function, I get -1. I put 0 in, I get 0. I put a +1 in, I get +1. I put a +2 in, and that's a 3, I get +8. So graphing that, I have -2, 6, 7, 8. I get -2, 8. -1. Not sure why I did that. I'm sorry. I was having a moment. Erase. Draw. All right, let's do that again. -2, -8. -1, -1. 0, 0, 1, 1, 2, +8. This is your parent function for a cubic parent function, which is, of course, f of x equals x cubed. So these then, right here, are your anchor points that you need to know. But, you don't really need to memorize them because you can easily find them. If you remember your x values, you remember these, you can always find your y values, right? You just plug them in. Now, when you're looking at this cubic for the parent function, the domain, x can be positive, x can be negative. The domain is all reals. And we talked about that on Friday, how odd functions are going to have a domain of reals, and the range is also reals. All right, so there's your parent function, and we're going to transform that in a little bit. Incidentally, if it was f of x equals x to the 5th, the parent function is very similar. It's just steeper. And x to the 7th, very similar, just steeper. And so you really can find any of the parent functions for any of the odd polynomials based on this. All right, moving down. Example 2. Find the graph. And so this is x to the 4th, which is an even polynomial. We're going to do the same thing. First, we're going to complete the table of values. So again, this is your parent function for a quartic. which is f of x equals x to the fourth. All right, so put negative 2 in there to the fourth power. Well, now when we do it to the fourth power, the negative is gone and we have 16. Put negative 1 in there to the fourth power, the negative's gone and we have 1. 0 to the fourth is 0. 1 to the fourth is 1. 2 to the fourth is 16. And so here we get that parabola-looking equation. So our graph is going to look like negative 2 to the 16, so we're way up there. And then we have negative 1, 1. We have 0, 0. We have 1, 1, and 2 to the positive 16 again. And so there it is. It's very steep. Okay, because obviously these points right here aren't even to scale. The domain, x can be positive, x can be negative. So the domain is reals. But the range for an even degree is limited. And so y has to be greater than or equal to 0. So from this right here, and you already know what this graph looks like, right? X squared. You can graph any even degree function, like a parent function. If I say f of x equals x to the 6, it's very similar. These numbers are just going to get steeper. That's all that's going to happen. And the graph gets steeper and steeper and steeper. Okay, so now example 3. Now we're going to do transformations. Identify the parent function, describe the transformation, use a table to graph each function, and state the domain and range. All right, so looking at this equation, there's a lot going on. We have the 1/4 outside the function, which means we have a vertical compression of 1/4. It's outside the function, so we don't do the opposite. That's a vertical compression. Then we have this 2 right here. Now notice that 2 is being cubed. So that 2 is inside the function, which means we have to do the opposite to that 2. So then we have a horizontal compression of 1/2. So there's where we do the opposite, because that 2 is inside the parentheses that's being cubed. Then we have this -5, which is also being cubed. And so we're going to say write 5. And then finally, we have this up 1 at the end, and that is outside the cubic, or the cubing. So then we're going to go up 1. So we have 4 different transformations happening. Now this is a cubic. So for your x values, just stick with -2, -1, 0, 1, 2. You can look up at the top of your notes to find those y values, or you can just plug those in to the parent function. Remember, the parent function here is f of x equals x cubed. It says identify the parent function, so make sure you have that written down somewhere. That's your parent function. So -2 cubed is -8. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. And now I have to perform my transformations. So what am I doing to my x? These are the ones for the x right here, that and that. So I'm going to write 1/2 x plus 5. All right, and what am I doing to my y? These right here is what's happening to the y. So I'm going to do 1/4 y up plus 1. And I'm going to apply those transformations. So -2 times 1/2 is -1 plus 5 is 4. -1 times 1/2 is -1/2 plus 5 is 4.5. 0 plus 5 is 5. 1 times 1/2 plus 5 is 5.5. And 2 times 1/2 is 1 plus 5 is 6. So there's my x values. My y values, -8 times 1/4 is a -2 plus 1 is a -1. -1 times 1/4 is a -1/4 plus 1 makes, I'm looking at my notes, I think I have it wrong. If I have, let me just scribble that down so I don't continue to do it wrong. that means I have negative 1/4 plus 4 over 4 equals 3 over 4. So this is 3/4 or 0.75, either way. 0 plus 1 is 1. 1/4 plus 1 is 1.25. And 8 times 1/4 is 2 plus 1 is 3. So there's my points. Let's graph them. I have 4 and negative 1. I have 4.5 and 3/4. This is going to be tight. All right, I got 5 and 1. I have 5.5 and 1 1/4. And then I have 6 and 1, 2, 3. And there is the graph. All right, the tricky thing here is these numbers. Just be careful with them. If you look at my notes, you'll see that there is a mistake right there for that 0.75. The domain is all reals. The range is all reals. Okay, let's do another transformation. So first of all, it says identify the parent function. So looking at that, I see my x is here, and it's to the 4th power. So the parent function here is f of x equals x to the 4th. So I know I'm looking sort of like a parabola, right? All right, so let's go through our numbers. This number is outside what's being to the 4th power. And so, whoa, wowza, hold on. Okay. So therefore, that 2 is a vertical stretch of 2. All right, the 1/3 is inside what's being taken to the 4th power. So that means it's messing with the x, and I have to flip it. So I have a horizontal stretch of, I flip it, and I have a 3. Then I have my x, and I have a -1. That's also being raised to the 4th power, so that means I'm going to go right 1 instead of left 1. I do the opposite. And then finally, I go down 4. So just remember, as you go through these, anything inside this 4th power has to be the opposite. Anything opposite or outside that 4th or that exponent of 4, you do the exact thing. So just keep that in mind. Okay, so anchor points for my quartic. I have -2, -1, 0, 1, 2. I should change that color. Okay, each of those taken to the 4th power gives me +16, +1, 0, 1, +16. So now what am I doing to my x? I'm doing this to my x, and I'm doing this to my x. So I have 3x plus 1. And what am I doing? Oh my goodness, hold on. What am I doing to my y? For my y, I have this and this. So that would be 2y minus 4. Okay, so we're going to plug those numbers in. Let's do the x's first. 3 times -2 is -6 plus 1 is -5. 3 times -1 is -3 plus 1 is -2. 0 plus 1 is 1. 1 times 3 is 3 plus 1 is 4. And 2 times 3 is 6 plus 1 is 7. So there's my x's, my y's. 2 times 16 is 32 minus 4 is 28. 1 times 2 is 2 minus 4 is -2. 0 times 2 is 0 minus 4 is a -4. And then 1 times 2 is 2 minus 4 is -2. 16 again will give me a 28. So my graph looks like this. I have -5, 1, 2, 3, 4, 5, +28. I'm just going to stick that right up there and label it 528 because that's way off my graph. And then I have -2, -2. Then I have +1, -4. Then I have +4, -2. And then I have 7, positive 28 again. So I just label that. That should be a negative 5, by the way, 7, 28. So make sure as you graph these, all this spacing between those points, the spacing between those points, they should all be equal. And you draw your parabola like that. Domain is all reals. X can be positive and negative. Y, the range is limited. This time Y will be greater than or equal to that lowest point, which is the Y value of my vertex, which is negative 4. All right, moving on. Example 4. Let g of x be the indicated transformation of the parent function of x to the 5th. So there's our parent right there. Write the transformation rule and the equation. All right, so we have a vertical stretch by a factor of 4, a translation 6 units left and 1 unit down. So we're going to say we have f of x. Oh, first it says write the rule. So let's write that rule. xy maps to, what are we doing to the x? Right here. Just as a reminder, the rule, oops, I don't know why I put a parentheses, go away. Okay, the rule and description are the same. It's in the equation you do opposite for x. All right, so when it says write the transformation rule, that means I don't do any of the opposite business here. So here, the only thing happening to the x is that I want to go 6 units left. So I write x minus 6. And then, of course, for y's, we never do the opposite. So y is going to be, whoa. Oh, my. Okay, there we go. Y is going to be 4y minus 1. There's my rule. And the rule and the description are exactly the same. But now when I write my function, I'm going to write f of x. The y stuff doesn't change, so I put my 4. And then I have, here's my x. So that's where I do the opposite. Make sure you put that 5th power in there, because that's what our parent function is, minus 1. Okay, next one. Reflection across the x-axis, horizontal shrink by a factor of 1/3, a translation 2 units right and 8 units up. So we have 4 things happening. So let's just start with our rule first. Remember, when we write the rule, it's exactly as it says. So what's happening to the x? We're going to have a horizontal shrink by a factor of 1/3. So I have 1/3 x. And then I'm going right 2 plus 2. And then what's happening to the y? The reflection across the x-axis, that's actually happening to the y, plus 8. There's my rule. Now when I write this, you got to be careful here. So I'm going to write the function f of x equals, the negative comes first right here. And then I'm going to have a, where is it? A horizontal shrink. This 1/3, when I put it in my function, I flip it. And then you have to also take it out like that. And so then I go x minus 2 to the 5th power plus 8. I want you to make sure to take a good look at this, especially right here. That is how you write that. In the transformation rule, the x inside the parentheses has to have a coefficient of 1. So therefore, if there's a number next to that x, like right here, you have to take that out, put it outside the parentheses. Be very careful here. This is the trickiest one of all the transformations. All right, when you have both a horizontal compression and stretch and a horizontal slide. So here we have 2 transformations for the x, compression and stretch and a slide. then you have to factor that 3 out. But you're not truly factoring it because notice that -2 doesn't change value, right? You just write the 3 out there like that. So be careful there. Okay, example 5. Let k of x be the indicated transformation of the parent function x to the 6. So this time we are doing an even one. Write the transformation rule and the equation. So we have a reflection across the y-axis. So that's actually happening to the x. Horizontal stretch by a factor of 5. A translation 9 units left, 4 units up. Again, we have 4 things going on. Let's write the rule. What's happening to the x? This is happening to the x. This is happening to the x. This is happening to the x. How do I write that? Well, when I write the rule, I write it exactly the way it says. So I have a reflection across the y-axis, so I put a minus sign. Horizontal stretch by 5. Minus 9. That's what's happening to the x. What's happening to the y? Only here. Y plus 4. So there's my transformation rule. And now when I write the function again, this is where you got to be careful because right here you can see you have 2 things happening to, actually 3 things happening to your x, right? So you're going to write your function as f of x equals, first of all, we have to do the opposite. So this is going to be a 1/5. Don't forget that negative sign. Put a parentheses, x plus 9. That's how that looks. So I have a double parentheses at the end with a 6 up there. And then plus 4. So again, here's a good example. Be very careful when you have both a multiplication times x and a slide. You have to take that multiplication out. Okay? Last one, vertical shrink by a factor of 1/2. Horizontal shrink by the factor of 1/6. 3 right, 7 down. All right, let's write the rule. We have xy goes to, what am I doing to the x? Right here and right here. And the rule goes exactly with the word, so I have 1/6x plus 3. What's happening to the y? That would be this and this, so I have 1/2 y minus 7. There's my rule. To write the function again, you should notice, of course, right here you have both going on again, so be careful there. You're going to write your function is f of x equals, do the opposite, so I write that as a 6, parentheses x minus 3, end of parentheses to the what power? 6th power. I forgot that 1/2. That 1/2 goes right here. Minus 7. And there's the function. So you can see we are doing more complicated transformations because you have been doing these since August. So if you need, pull out your old notes and review your transformation rules because it is expected that you can follow this. The only kind of new thing here is that we are making our x transformations more complicated, and you have to take this and turn it into that. All right, and that is the end of our lesson.